desire to create machines that can think, learn, and perhaps even feel. However, the history of AI isn't just about machines. It reflects our own curiosity, limitations, and aspirations, revealing as much about human nature as about technology itself. The origins of AI trace back to the mid-20th century, shaped by a small group of visionary thinkers, most notably Alan Turing. In his seminal 1950 paper, Computing Machinery and Intelligence, Turing posed a fundamental and provocative question: can machines think? To explore this, he proposed what would later be known as the Turing test, a practical method to evaluate whether a machine's behavior could be indistinguishable from that of a human. This test became the gold standard for assessing machine intelligence and laid the philosophical groundwork for the entire field. Despite the profound nature of Turing's insights, however, creating a truly intelligent machine proved far more challenging than anyone initially imagined. At that time, the technological landscape was vastly different from today. Early computers were enormous, prohibitively expensive, and possessed only limited processing power. They could not manage the massive data sets or complex calculations necessary to emulate human cognition. AI research was largely theoretical and exploratory, relying heavily on symbolic reasoning, the idea that intelligence could be modeled by manipulating symbols and following logical rules in a top-down fashion. This approach assumed that all aspects of thought could be broken down into formal systems and algorithms. Yet this symbolic approach soon ran into significant hurdles. As problems grew more complex and real-world data proved messier and less predictable than pure logic, symbolic AI struggled to scale or adapt. It became clear that human intelligence was not just a matter of rule-based manipulation, but also involved intuition, learning from experience, and pattern recognition, capabilities that symbolic AI couldn't easily replicate. These limitations contributed to several periods of disillusionment known as AI winters, during which funding and interest dwindled and progress appeared to stall. Researchers faced not only technical barriers, but also philosophical debates about what intelligence truly meant, highlighting the profound challenges in replicating the human mind. Despite these setbacks, AI persisted as a field of study, driven by the relentless curiosity and ambition of researchers who saw its transformative potential. Over time, advances in computer hardware, the availability of large data sets, and the development of new learning algorithms began to revive AI. The shift from symbolic AI to more data-driven statistical methods like machine learning and neural networks opened new pathways, allowing machines to improve performance through experience rather than relying solely on pre-programmed rules.